All right, so we've got some vocab here. That's okay. Got some vocab here. Let's get it written down first. So a scale drawing is a proportional two-dimensional drawing of an object. A scale model is a proportional three-dimensional model of an object. Anybody ever made a model car or made a model airplane before? Anybody ever owned a Matchbox car? Or Hot Wheels? Matchbox or Hot Wheels?
Oh yeah, Hot Wheels.
Those are scale models. I think the scale for those, actually, I'll explain the scale in a second, because you guys can read it. So the measurements in scale drawings and models are proportional to the measurements of the actual object. They're proportional, which means that the relationship between the size of the wheels and the size of the door and the size of the windows on those model cars, they're all the same on the model as they are on the actual car. The relationship between them. So if the windshield is twice as big as the side window on an actual car, on the model, the windshield is going to be twice as big as the side window on the model car. That's what it means to be a scale. Scale gives the ratio that compares the measurements of the drawing or model with the actual measurements. This is how we write it. Notice drawing comes first. Here's the big thing. Underline this. Scales are written so that the drawing distance comes first in the ratio. That first number will always be the drawing distance. So like I said, you guys had Matchbox or Hot Wheels cars. I think the scale for those is 1 to 55, which means that for every 1 inch on the Hot Wheels or Matchbox car, it corresponds to 55 inches in the real world. I think it's that. The Lightning McQueen and like Disney cars, like Pixar cars, I think those are 1 to 45. Means for every inch on that Disney car, if we were going to have it in the real world, I know it's Pixar, so there's no real world, but in the real world, it would be 45 inches. There are some model cars that are 1 to 25, which means for every 1 inch on the model car, it only corresponds to 25 inches in the real world. So notice, in every single one of those relationships, the drawing distance came first, or the model distance came first. Okay? Sometimes models can actually be bigger. Sometimes models can be smaller.
Wait, no, what about you do that?
Yeah, we'll get there. Think about it. Anybody ever had something be bigger than when it was designed? Right? So like blueprints for a house, a model, doll houses. They're smaller than the actual thing, right? Sometimes things are actually bigger. What about if you had an image of a tick in a textbook? Do you think that image would be larger than the actual tick?
I'll be real size.
Wait, what?
What about the image of a mosquito? Do you think the image in your textbook probably might be a little bit bigger than the actual mosquito? So sometimes drawings and models can be bigger, sometimes it can be smaller, right? Like a Matchbox car or a dollhouse. Some of it can be bigger, like if I need to blow up an image of a really small object. Anybody ever seen a picture of an atom? Yeah. Yeah, you have to zoom in like crazy, right? So sometimes the image can be bigger. So be aware that sometimes the number that's first is going to be larger. Sometimes the number that's first is going to be smaller. And that tells you which it's going to be. Ask the question.
I was gonna say, well, would that work? You know, in the cereal boxes, how it's like enlarged and shrunken.
Yes,
Would that be the same?
absolutely, especially if they enlarged it to scale. Enlarged to show detail. That's a great example. Yep. So here we go. We want to figure out what the scale or ratio is. We aren't solving for anything. We're just figuring out what the scale is. That's why this part of the notes is going to go really fast. Okay. So right away, a sketch of a fashion designer's T-shirt is 9 centimeters long. Everyone, show me what you think 9 centimeters is. Centimeter across is usually about your fingernail. If you pick your fingernail, it's about a centimeter. 9 centimeters is about that big, right? About like that. Something close there. Think of like an apple. That's about 9 centimeters long. The actual shirt is 1 meter long. Show me what a meter is. It's a double extra large. It's like a meter. It's like a meter right here. Oh, you said nose to finger?
Nose to finger and about 3 inches.
Oh, I didn't know that. That's cool.
Nose
Makes sense, I'm 5'6", so half of me would be 2'9". So
Yeah.
3 feet is about a meter. Wow, that is really cool. So there's a meter. What is the scale of the drawing? Okay, well, remember, scales are written so that the drawing distance comes first in the ratio. So we first want to put the drawing distance first. What's the drawing distance?
9 centimeters.
9 centimeters. What's the actual distance?
1 meter.
1 meter. So is the scale drawing larger or smaller than the actual object? Is the drawing smaller or larger? Well, but it's 9 to 1.
But it's centimeters
So
in
it's
unit.
centimeters.
I gotta think. The number that's bigger is on top, right? But the distance that's bigger is on the bottom. And which one comes on the bottom? Or comes second? The actual. The actual one comes second. Right. So yes, it is in fact smaller. The drawing is smaller. Okay? That's all that example is. You weren't supposed to see that. Whatever. It's okay. We'll get it. We'll figure it out. I must not have gone through and pulled everything out. So let's read with it. The scale model of Sergeant Floyd Monument in Sioux City is 10 inches tall. So it's like you go to the gift shop and buy an image. Anybody ever seen the Washington Monument on CNN 10? Right? You can buy little models of that, 10 inches tall. So here's this monument. This is in Sioux City, Iowa. It's like a mini Washington Monument. The actual monument's 100 feet tall. What's the scale of the model? Well, what's the first thing we need to look for? The drawing distance, or in this case, the model distance, right? Because it's not a drawing, it's a model. It's like a gift shop model. And that is going to be what? 10 inches over, and then 100 feet. Because we have our model distance over the actual distance, and that is going to simplify, right? We can simplify that to be 1 inch over 10 feet. And we need to have our units here because is the model larger or smaller than the actual object? Yeah, it's 1 inch to 10 feet. It's important. It's 1 inch, that represents 10 feet. Okay? All right, a scale image of a spider is pictured here.
5 centimeters.
The actual spider is 10 millimeters long. That's small, huh? What is the scale of the drawing? Well, what's the first thing we look at? Look at the top.
We're going to check this, how big the spider is in the design.
What's the drawing, right? How big is the spider in the drawing, in the image?
5 centimeters.
5 centimeters. How big is it in the real world?
10 millimeters.
Good, so write out your ratio. What is it going to be?
5 centimeters. 10.
Picture over actual. Refer to that image at the top. Refer to that information at the top every time. That's study tip. The image comes first. That would simplify to 1 centimeter for every 2 millimeters. So is the scale image larger or smaller than the actual object?
Larger.
It's larger. Why?
Because in the picture it's 5 centimeters, but in real life it's 10 millimeters, so 10 millimeters is smaller than 5 centimeters.
Exactly. And when you look at the scale, 1 centimeter is larger than 2 millimeters. 1 centimeter is that big, 2 millimeters is very small. 2 millimeters is how much I cut off my thumb. When I sliced it through. So it would be larger in this case. Another thing that you can think about is like saying 10 millimeters for every 2 millimeters, right? So if you're unsure about which one's smaller, which one's bigger, get them to have the same units. If you're unsure, well, Mr. Strand, 1 is smaller than 2. You're absolutely right. 1 is smaller than 2. But 1 centimeter is bigger than 2 millimeters. Why? Because 1 centimeter is 10 millimeters. Okay? Okay, let's write some proportions now. So now we're going to use a scale to help us figure out proportions. There's 3 different things we're going to come up against on our homework today. Talk about maps. Remember how the scale is the drawing over the actual? Well, if we're talking with maps, we have maps over actual. If we're talking about models, it's going to be models over the actual. If we're talking about drawings, it's going to be drawings over the actual. In every one of these cases. So we're going to refer back to that every time. So you're going to be given one ratio. That ratio is our scale. The other ratio is the information from the problem. So we'll have the scale, and we'll have the information from the problem. We are going to be missing one of these. Okay, so that's what we'll have to figure out. All right, given the scale, 7 inches is 30 miles on a map. Okay, so that's our scale. 7 inches, that's about that. That represents 30 miles on a map. Find the actual distance if the map is 14 inches. Well, this one you might be able to do without doing much thinking. Can you do this one without setting up a proportion? Do it in your head. What is it? 60 miles. Good. Let's set up a proportion just to practice, since we already know what the answer is going to be. How do we know it's going to be 60 miles? Yeah. The scale is 7 inches, equals 30 miles. On the map it's 14 inches, that's twice as big. But let's practice it up. So we start with a scale, okay? Start with the scale. So what's our scale?
7 inches over 300 miles.
Good, 7 inches over 300 miles.
30 miles.
30 miles, thank you. I said 300, but I wrote 30. I said it incorrect. And what's that going to be set equal to? So once we start with the scale, then the problem. What's the information given in the problem?
14 inches.
14 inches. Is that going to go on the top or is that going to go on the bottom? Good. How do we know that? Did you see how we wrote inches on the top? Guys, 7th graders really push back about this whole writing units thing down. Like on the story problems when I was like, you gotta have your units. Like 50 to 60% of people don't write the units. The units help you set up the proportion. And then X is gonna go on the bottom. Another thing you can do is instead of writing the units in the problem, you can decide in the beginning, remember this one's map over actual. Okay, map over actual. And now, to multiply this stuff, we notice that 7 inches is times 2, so 30 inches is times 2, just like we talked about. So X is then 60 miles. Okay, this time we want to find the drawing length on the map if the actual distance is 500 miles. This is where your calculator might be useful. Did I tell you to pick up a calculator? No. Sorry. Don't get it out now, just trust the people who have a calculator to help you out, okay? So those of you who have your own calculator or borrowed one, just trust each other. No, just trust the people who have them, okay? So we said we want to start with the scale, right? So scale first, and then we go to the problem. Okay? Keep in mind, it's map over actual. So what's our scale?
7 inches.
7 inches over 30 miles. What's that going to be equal to? X over 500 miles. Now, you could use common multiplier here, but it's not a nice common multiplier, so we're going to use a different strategy. What strategy is that? Let's find cross products. So 30x. 7 times 500 is the same thing as 7 times 5 with 2 zeros. What's 7 times 5? With 2 zeros? 3,500 or 3,500? Yep, it's one of those two. And then to get x by itself, we divide both sides by 30. Here's where our calculator is going to come into play because this is not a nice division. It's an approximation. Let's round our answers to the nearest tenth. Anna?
About 116.7.
So it better be a big map, right? Better be one of those wall maps. Because it's 10 feet. 116 is pretty close to 120 inches, right? 120 inches is 10 feet. So it's going to be one of those wall maps that you see in like big museums. Questions on this problem? Yes?
So how do we get in around 35,730? How do we get like 116?
Anna did the division here.
Okay.
And then because it's not a nice division, it has decimals. I think it's 116 and 2/3, right?
It's 116 and yeah.
Is it 116.6 repeating?
Yeah.
So it's 116 and 2/3. But I asked you just to round your answer to the nearest tenth. Thanks. All right, questions on these two? Let's go to example 5. I'll let you guys do example 6 on your own. Okay, here we go. Let's read the problem together, make sure we can find the information that we need. All right, what's our important information that we're going to need on these problems? Yeah?
The actual side of the model.
Yeah, that's called the scale. We need the scale. The liquid core of Earth is 23 kilometers thick. A scale model of the layers of Earth has a scale of 1 inch is 500 kilometers. How thick is the liquid outer core of what? The model. Why is that important that we identify that? Why is it important that we're identifying that the question is asking for the model? That means that we don't know the model. It's in the question, right? That's our variable. It's in the question, it's going to be our variable. So let's set this up. What comes first in our proportion? Jeremiah? 1 inch, yep. Let me back up a step. What should we write on the left side of our proportion? Our scale. On the right side should be our problem. Remember, ladies and gentlemen, these are notes. So you should be writing more stuff than you would write on your homework, right? To give you reminders. That's why I do this on the notes. Like, would I do that on my homework? Probably not. But I'd be using my notes in my homework so that I would be able to make that connection. So the scale, Jeremiah, 1 inch over what?
500 kilometers.
Good. That's going to be equal to, keep in mind that this is model over actual, right?
X over
X inches over,
2,300.
good, 2,300 kilometers. And this one's not a nice multiplication either, so I'm probably going to use cross products. I'm going to get 500x equals 2,300. Now to get x by itself, here's where that calculator can come into play. Anna's not the only one with a calculator. Jeremiah? 4.6 what?
Kilometers.
Nope.
Oh,
What were we looking for?
inches.
Why is it going to be inches?
Because that is model.
Yep, see how it says how thick is the liquid outer core of the model? All right, you and your partner do number B, or letter B. Go. Your partner talk through letter B, talk through the setup. What's coming first? Oh, I forgot to make a change on yours. On your, darn. We'll make that change. Number 6 is different. I forgot to make that change on your guys's. Why did you not do part B? Give part A, part B, part B. So notice this one was, the first problem was talking about the liquid outer core. The second part of the problem is talking about the mantle. So the liquid outer core, that's this dark brown one. The mantle was this one. So the mantle is solid, the liquid outer core is here. Do you guys know where the plates are? Where the plates?
Yeah, the tectonic plates.
Yeah, the tectonic plates. They're right above the crust. So the crust floats on a a layer of hot molten magma. That's what comes out of volcanoes. So you've got your mantle, which is solid, then your liquid outer core, then your solid inner core. I'm not sure what the solid inner core is made of. It's made of some types of metals, but I'm not sure what. It's a question for your science teacher. I'm not sure. All right, now on your notes, I forgot to make this change. So read this and make the change on your notes, please. Using no pictures. No pictures. The scale of a drawing is 10 meters to 12 centimeters. Is the scale drawing larger or smaller than the actual object? So change those numbers to 10 meters and 12 centimeters. So don't even do any, there isn't any math to do.
Oh, yeah.
Kind of.
I need her.
Don't forget, so we have this information at the very beginning of our notes. Scales are written so the drawing distance comes first in the ratio. So, is the drawing larger or smaller than the actual object?
What are DMs?
I asked you to change it. DMs are decimeters.
Oh.
We don't use them very often, so that's why I changed it to this, but forgot to change it on your notes. I apologize. Actually, I did change it. I just printed off the wrong copy. Printed off the old version.
I get it.
So, larger or smaller?
Larger.
Let's take a look at why. Okay? So we know that it's drawing over actual. So 10 meters over 12 centimeters. Which unit is bigger, right? 12 is bigger, but meters is bigger. So that means the drawing is bigger because meters are greater than centimeters. So another way of thinking about this is it's like saying 1,000 centimeters over 12 centimeters. This is like a mural, okay? It's like if you were making a picture, you had a painting, and then you wanted to make a mural of it. Do you know what a mural is?
Yeah,
Yeah, it's like on the side of a building. So that would be like what this is. For every, right, you take a picture and you want to put it up on a building, on the side of a building. This would be a scale to do that. For every 12 centimeters on your paper, right, in the actual painting that you've done, 10 meters on the building.